Let's take a look at this example. Before we are going to start solving this problem, you're supposed to again realize that we are dealing with the parallel circuit and that voltage source in this case is equal to VR and this is also equal to VL. So in order to find voltage source, I can find VR because this is going to be the same value. Okay, so please notice that I have given current which goes through the resistor and I have given resistance. So I can use Ohm's law to find the voltage VR. Okay, so we have VR is equal voltage source. This is also equal to VL. This is equal IR times R, where IR is equal 80 milliamps times R 300 ohms. So VR is equal 24 volts and at the same moment this is also voltage across voltage source. Okay, source voltage. So I found voltage source. Next, I'm supposed to find the frequency. Please notice that we have given X of L and we have given L. If you are going to write the formula for the inductive reactance, X of L is equal to 2 pi FL. We have inductance, we have X of L. We can find F by solving this formula for F. So F is equal X of L over 2 pi L. X of L is equal 100 ohms over 2 pi times L, which is equal 50 millihenries. 318.31 hertz. So I found the frequency. Next, we're supposed to find the true power in the circuit. P is equal IR times R, of course, square. So IR is equal 80 milliamps square times resistance, which is equal 300 ohms. Please notice that the problem is not specifying if this is peak or RMS value of the current. So if it's not given, I assume that this is RMS. Okay, if there is no peak, I assume that this is RMS. So this is equal 1.92 watts. Okay, so this is the true power in my parallel circuit. In order to find power factor, I need angle theta or value of Z total. I don't have both of them. So what I'm going to do first, I'm going to use the formula for the product over the sum in order to find Z total. So I have Z total equals R times X of L over R plus X of L. I have R equals 300 ohms times X of L, which is equal 100 ohms, an angle of 90 degrees, over 300 ohms plus 100 ohms, an angle of 90 degrees. So my Z total is equal 94.86 ohms, an angle of 71.56 degrees. This is my Z total. Please notice that at this moment we got the value, we got the magnitude of Z total and we got the angle. So very easy we can find the power factor. Power factor is equal cosine of angle which is next to Z total. So this is equal cosine of 71.56 degrees. This is equal 0.316, and of course this is lag because we are talking about the RL circuit, and current in this circuit, the total current in this circuit is going to lag the voltage source by angle 71.56 degrees. Next, we have to find the series equivalent circuit. So I have my Z total, which is equal 94.86 ohms, an angle of 71.56 degrees, and I have to convert polar form to the rectangular form. This is equal 30 ohms plus J 90 ohms, where the real part is my resistance S and imaginary part is my X of Ls. So I found Rs and X of Ls. Next, I'm supposed to find the inductance of the inductor in the series equivalent circuit. Again, we're supposed to use the formula for the inductive reactance. So I have X of Ls is equal to pi FLS. Okay, so we have formula, and in order to find Ls, I have to solve this formula for Ls. So if Ls equals X of Ls over 2 pi F. I'm going to continue over here. So I have Ls is equal, X of Ls has value 90 ohms over 2 pi, the frequency, and we found the frequency, this is 318.31 Hertz. This is equal 45 millihenries. Now we can draw the series equivalent circuit. I have voltage source, I have Rs, and I have inductor Ls. We found that voltage source has voltage 24 volts, Rs is equal 30 ohms, and Ls we found is equal 45 millihenries. Also, you're supposed to realize that the total current, right, in my series equivalent circuit is going to be equal to the total current in my parallel circuit. In order to find I total, we're supposed to simply use the Ohm's law. I total is equal voltage source over Z total, where voltage source is equal 24 volts and Z total is equal 94.86 ohms, an angle of 71.56 56 degrees. This is equal 253 milliamps and angle of negative 71.56 degrees. So this is the total current in my series equivalent circuit and in my parallel circuit. You're supposed to realize that if we talk about the series circuit, so I total is equal to IRS, and this is also equal to ILS because this is series circuit. In series circuit, current is the same at every single component. So you're supposed to realize that this is equal to 253 milliamps and angle of negative 71.56 degrees. If I want to find the true power, I'm supposed to simply write PS is equal IRS raised to the second power times RS. 253 milliamps raised to the second power times RS, which is equal 30 ohms, is equal 1.92 watts. If you are going to compare the true power in series circuit and true power in parallel circuit, you will see that both of them are identical. Okay, this is the value which we got before for parallel circuit. So if they are identical, it means that we solved the problem correctly.